Year 11 mock exam, question 1, off we go. So first question is actually 4 answers to this question. It says give, which is basically a similar command word to state, one substance that can react with an acid to form a soluble salt. The most straightforward answer would be to say alkali. But it's also acceptable to have metal hydroxide, to have metal carbonate, or just in fact to say a metal, because all of those will produce a salt. What you cannot say, because it has already said it in the root of the question, is a metal oxide. Question 2, calcium nitrate ions contain calcium 2 plus and nitrate minus. Give the formula for the calcium nitrate. Quite a low demand question because they have told you the ion for nitrate. This actually is one of the ions you need to remember, but they've told you. This, of course, you can find in the periodic table because it's group 2, and so all group 2 metals form 2 plus ions. So we write our formula like this. This is perfectly acceptable. Might seem a bit strange at first. And now we can work out how to balance the charges. We can either say, well, we need 2 nitrate ions because we need 2 negative ions to balance the charge on the 2 plus from the calcium ion, or we can do this simple trick where we move down like this, the numbers, and so we end up with a 1 and a 2 there. So the answer is Ca, and the tricky bit here is this has to be in brackets. And there we go, CaNO3 brackets 2. The main question here, and this is a challenging question for some people. Describe, as our command word, a method to make a pure, dry, really important words here, magnesium sulfate, crystals of magnesium sulfate from a metal oxide and a dilute acid. So this is a 6-mark question. First of all, we need to know what substances we need to react together. Now, this is a procedure, not a investigation, which means we do not have to state variables. There's no independent, dependent, or controlled variables. But what we do have to do is write in steps. But before doing that, and this isn't essential that you do this, but I'm going to write a word equation for what we're going to do to get magnesium sulfate. So I'm going to write down here that we need to get some way to get the magnesium. Magnesium is going to come from the metal oxide. So we need magnesium oxide plus, and we need some way to get the sulfate. We need an acid with a sulfate, an acid with an S. It's sulfuric acid. Let's use the American spelling. Goes to magnesium sulfate, which is what we want, plus water. Now, as I said, that's not essential, but I've written as a word equation, not as a chemical equation or a formula equation. Why? Because if you write the formula equation wrong, if you wrote HSO4 instead of H2SO4, it would not count, which is why I've written in words. It's very important. So it's really important, unless you're asked to, try and stick to using words instead of chemicals. Of course, you can later abbreviate, so that's what I'm going to do. And even if you abbreviate later incorrectly, you still can end up with the marks. Now, we're going to write in steps here. Don't write step 1, just do a 1 there with a mark next to it. And we're going to say, take 25 milliliters of sulfuric acid into a beaker. I'm going to state what we're using to measure. Measure with a measuring cylinder. important to state the devices you use. This 25 mils is not so important because you don't have to have the exact quantities. You can say 5, 10, you can even say 1. Might be a bit unreasonable if you started taking litres, but it's not actually that important to the question. So take 25 milliliters of sulfuric acid into a beaker, measure with a measuring cylinder. Step 2, we're going to heat the acid. Now at this point I can say heat the acid because I've already referred to it as sulfuric acid. I don't need to refer to it again, so I can just say heat the acid. It's not going to cause any problems. Heat the acid. Do not say warm the acid. Heat is the important word here. You can put a temperature of 60 degrees, but that's not as important. Question 3, or step 3. Okay, this is the metal oxide is a solid, so we're going to use a spatula to spoon the metal oxide in. So add the magnesium oxide with a spatula until the magnesium oxide is in excess. That's a very important term, with in excess. So that means that every time we're adding the magnesium oxide, it's reacting. It looks like it's disappearing, but I wouldn't say the word disappear. You just keep adding it while it reacts, and then eventually there'll be black powder left, whatever color magnesium oxide powder is, I forget now, but there'll be powder left behind. But you can just say until the magnesium oxide is in excess. So now we've got an excess of a solid, and we want to get rid of that solid now. So what do we need to do? So we need to filter this, but it's important not just to say filter, to actually say the equipment we're using. So use a filter funnel and filter paper to filter out the excess solid magnesium oxide. So now what we have is a pure solution of magnesium sulfate. So now we need to remove the water. So we can heat I'm going to use the abbreviated term, MgSO4 solution with a capital P for Bunsen burner in an evaporating dish until 2/3 has evaporated. Okay, so until 2/3 of the water has evaporated. So now we're going to leave in a warm environment to evaporate the rest of the water. And finally, and this is an important term, 7, pat dry. Now that's a very important term. Pat dry the crystals. I've left off one thing actually here. So leaving a warm environment to evaporate the rest of the water. And really we should add here until the crystallization point is reached. Okay, so that's basically saying until the crystals form. So we're going to pat dry the crystals to obtain a dry sample. So there we have a good model answer there. Okay, importantly, we've identified the two things we need to react together, the magnesium oxide and the sulfuric acid. We've gone through the main steps, the adding the two together, the filtering out, the adding it to excess, the filtering to remove the solid, the heating to evaporate the water, and patting dry the crystals to obtain a dry sample. So that's a good 6-mark answer to that question.